shown in the previous photo, it's always a good idea to mark out the position of the centre of where the workpiece needs to be set up. In this case, I've marked out exactly the centre of the four sides of the square and drawn a circle using dividers. Sometimes, depending on the application of the component, the centre may not be central to the four sides, it may be offset. We'll show that in a further section of the video. In this case, the square is going to be set central. As I previously mentioned, each of the four jaws can be adjusted independently. So we need some sort of a reference to try and get the four jaws in the same position relative to the centre of the spindle. For that purpose, four jaw chucks are normally provided with a series of concentric circles engraved onto the face of the chuck, which means that if you use a reference point such as the corner of the jaw, you can position each of the four jaws so that the corner of the jaw is at the same point relative to the concentric circles. And once that's done, the four jaws will be equally spaced relative to the centre. You can then try to see if your workpiece fits in. Not quite, so I need to move each of the jaws out away from the centre by the same amount. I'll then try the workpiece in again. It now fits. So I would then keep the workpiece held in the chuck while I tighten each of the jaws slightly until I've got a light grip on the workpiece. So each of the jaws are now lightly gripped so the workpiece is held, though not as tightly as it needs to be for machining. I will then spin the chuck, and I can see that the circle is moving eccentrically. If the workpiece was central, the circle would appear to stay still. If I lower the chuck guard and switch on the machine spindle, it can be seen pretty clearly that the circle, the described circle, is rotating in an eccentric manner. This means that the workpiece is not centralized. We need some sort of a reference point in order to centralize the circle. A common method for doing this is to use a parallel ground bar across the bed of the lathe with a surface gauge which has a fixed point which can be adjusted in height. The surface gauge would then be positioned so that it is in line with the circle. Like so. What you then need to do is to rotate the chuck 180 degrees. It can be seen that the point of the surface gauge is now not in line with the circle. This means that the workpiece needs to be moved in this direction to correct, and the amount it needs to be moved is approximately half the difference between the circle and where the point is. To do that, we need to loosen one of the jaws and tighten the opposite jaw. This should be done in small amounts. So I'm slackening this jaw and I'm going to tighten the jaw opposite. When I tighten this jaw, the workpiece is pushed slightly in that direction. I'm still not fully tightening the jaws. I'll then go back to the first position and realign the point with the circle. Repeat the process. I can now see that between that point and that point there is very little difference between the position of the pointer relative to the circle. I would then go to the next position. Jaws should always be adjusted in pairs. In other words, adjust this pair and then adjust this pair. To move the workpiece to correct, I need to move the workpiece in this direction, which means that this jaw should be slackened and this jaw should be tightened to move the workpiece in this direction. Once again, I'll slacken the jaw very slightly, move to the opposite side and tighten the jaw. I'll then check. Pointer is in line with the circle. Pointer is in line with the circle. Pointer is in line with the circle. And the pointer is slightly outside the circle. So I need to slacken that jaw and tighten that one. Reposition the pointer, and I can now see that the circle is in the same position relative to the pointer anywhere in the rotation of the chuck. I would then need to fully tighten each of the jaws to make sure the workpiece is secure, counting 1, 2, 3, 4 to make sure that I've tightened every single one. One final check to ensure that the circle is concentric and the workpiece is now set. As a final check, I'll turn the spindle on. It can be seen that the circle is still slightly off centre. I've now made a couple of small adjustments by just putting an extra bit of tightening on a couple of the jaws to get the final alignment. As we can now see, the pointer is at exactly the same position on the circle anywhere, and if I start to chuck, it can be seen that the circle is running perfectly central, so the workpiece is now aligned. As I mentioned previously, sometimes the component needs to have a hole drilled or a feature machined which is not central to the faces of the workpiece. I marked out the position of the centre on this workpiece, which is 2 millimeters off centre in one direction. And because the jaws can be adjusted independently on this chuck, it's perfectly suited for centralising this type of workpiece so that a hole can be drilled in an off-centre position. Once again, I'll align the jaws in the first instance so they're the same distance from the centre line of the chuck, using the concentric circles scribed on the face of the chuck. Match up my workpiece to see how close it is. Not far. Let's move the jaws back a little bit, same amount each. try the workpiece again. Now fits. In this direction, the centre line needs to be centred. So I will adjust the jaws so that the workpiece is lightly gripped in this direction, and so that the chuck jaws are approximately the same distance from the centre line relative to circles. In this direction, the workpiece needs to be offset from the centre line. In other words, it needs to be further that way. So I'm going to tighten this jaw so that this jaw is further in that direction than this jaw. Now, the workpiece is lightly gripped with all four jaws now. I can then position my pointer on the scribing block so it's approximately in line with the circle. And using the same method as before, I'll rotate the chuck and note the difference in position of the pointer. In this case, workpiece needs to go that way. I need to slacken that jaw and tighten that one. Which has now improved the situation. I'll check in that direction. The pointer is slightly inside the circle and just on the circle, so I need to slacken that jaw slightly and tighten that one. This direction needs to go slightly that way. Always adjust the jaws in opposite pairs. Makes it much easier to get a good result. I'll just turn the chuck on. It's fairly close. Could be better. Can be seen that the circle is now running pretty much true. It is possible to buy a 4-jaw chuck which is self-centering, like the 3-jaw self-centering chuck. As can be seen, when I operate the chuck key, all 4 jaws open and close simultaneously. This means that if I wanted to machine or drill in the center of a square piece of work, I could put the workpiece in and the 4 sides would automatically be centralized to the center of the spindle. However, this chuck has its limitations, as it can only grip a square piece of work centrally. If it's necessary to offset the workpiece in a 4-jaw self-centering chuck, spacers need to be made in order to offset the workpiece, and clamped in this direction.